the window. Oh, plug in the power. All right. Zoom in. Good. All right. Oh, goodness. 2 prop Z-tests. Just like a 1 prop, except we got 2 of them now. More on that in 15 minutes. All we got to do now is set up what we've got. X1 and N1, according to how you guys define the variables, are the garlic group. How many got codes with the garlic group?
24.
24 out of?
72.
Boom. 24 out of 72. How about the placebo group?
65.
65 out of the rest, which was 74, thank you. All right. Just make sure you get the sign correct. Make sure you get the sign correct. Okay? And then we draw, which I think you guys like it. I don't see a whole lot of area down there. Holy crap. There is not a whole lot of area down there because we're almost 7 standard deviations over. So we knew it was significant. We're over here on this board now with our data. Our data's over here on this board somewhere, which is pretty good evidence. It's pretty good evidence that we got a second curve, which means it appears that garlic. Good. I'm going to put a couple of the around the words garlic reduces colds. Right? If you don't mind, just a little bit more word, a little bit more. We don't need to get crazy wordy, but a little teeny bit of word. It appears that garlic's reducing colds. Of course, nobody in their right mind would accept this on its own. We definitely want to go back and look at the data again, control a little bit better for the variables, but it's interesting nonetheless. I always like studies like this, the ones that kind of shake the cage and get you to pay attention. One came across my Facebook page over the weekend. Somebody said they noticed a beehive in France. Was producing dark blue honey. It looked almost like blue paint. I was like, that's disgusting, first of all. You saw this? Have you saw this? M&Ms. They said the bees, instead of going to flowers to pollinate and pull nectar from flowers, they were actually going to a Mars plant. Mars, which makes M&Ms, which we'll be testing in here on Thursday. Hopefully not bee poop to spit on. And they were harvesting the sugar from that and bringing it back to the hive. Which I find very interesting, because I don't think bees would actually do that. Yellow jackets would do that. Wasps would do that. I don't think honeybees would do that. So that was, again, one little study that shook my cage and was like, I have to think about that. Because we do feed our bees sugar water in the late part of the fall, the early part of the spring when they're trying to come out. But sugar water, simple syrup, is very, very different when they put it in M&Ms. I mean, it's sucrose, if you will. But it's a more refined product. I can't believe that if a bee was given a choice between a flower and an M&M shell, they'd pick the M&M shell. But there's a little French beekeeper. And he's got this comb that's half yellow and half blue. Like, this could be a really good hoax, but it makes me want to go find out if this kind of thing is an outlier, like this might be, or if it's actually indicative of something else. And that's what small p, to me, friends, that's what small p-values are all about. They're about, okay, let's go back and look again. Can we replicate the study and get the same results, or even close to the same results? Or was it a fluke? Or was it just a bad study? Was it set up wrong? I don't know the answer to any of that stuff. Yeah? Cool? Alright, so you can tell the difference between 2 means and 2 proportions. I think, Danielle, you gave us the most important thing. When you said out of. Something out of, something out of, something out of. Good, very, very good. Very, very good. And 2 proportions versus 1 proportion is fantastic. But the idea is just being able to identify what you have to run. One of your exam questions for 2 weeks from now, or whatever it is, 2.5 weeks, one of your exam questions asks you to go and look for what are called non-parametric alternatives. We don't cover them that much in this class. You did it on your last project, on your bootstrapping project, which I don't have for you today because Emily hasn't picked them up yet. I'll get them to you soon. That was the BP oil well. We had to do that completely differently, because the data that you had in that project didn't fit the mold for what you're allowed to do, what we're doing in class. There are all kinds of restrictions on the kind of stuff that you can do with data, or at least that you should do with data. You can always take the average of a bunch of numbers, but you learn in 243 that sometimes you shouldn't. And if you shouldn't take the average of a bunch of numbers, you might want to think twice about testing the average of a bunch of numbers. What was the big kind of caution that I warned you guys against when you're taking averages? Make sure your data doesn't have a 1 or 2 or 3 or a large number of outliers that would pull the average one way or the other. Can you have outliers with proportions? No. You can't, can you? Because it isn't a scale of measure. It's simply, do you have the characteristic or do you not? If we were testing severity of colds versus just having a cold or not, that'd be a different measurement, wouldn't it? Rate your scale, or rate your cold on a scale of 1 to 10. 1 being, I'm perfectly fine, 10 being, please cut my head off because I'm leaking. That would be that would be an average. 1 to 10, pain scale, if you will, or a discomfort scale. Then you have to be careful. You have to be careful about the actual numbers coming in. Look at the shape of the numbers, make sure there aren't any outliers, that kind of thing. So that question on your exam, and this is introduced pretty well in the exam, go look at what are called non-parametric tests, which suppose you do have a lot of outliers and you still want to test your data. Well, there are ways to do that, and I have you guys just go to Google and find some of those. If you take more math classes, more stat classes, you'll actually get into constructing them. I used to do a lot more of those tests in class, but it got to be too much. I mean, you're experiencing the most commonly used tests in this class, but there are dozens of other ones that are used from time to time, like BP. But it just seems silly to hammer you guys with like 30 different tests in class when we can do like 5 or 6 and call it good, and you can learn the rest of it as you need them. I'm most concerned with making sure that you guys can know what a p-value is. That's my big thing. If you know what a p-value is, it doesn't matter what tests you run. All you gotta do is learn how to run the tests, and then you can understand the results from the tests, which is what brings us to our next data set. I want to make sure that was clear to you guys. Cool? All right, now let's take it further. This one